Okay, Crewton Ramone's House of Math. New lesson. You got your blocks, right?
Yep.
All right. So we'll get them right in front of you. You gotta get your hands on blocks. All right. So all you're gonna need is blue ones and units and stuff.
Okay.
All right. So let's start simple. And we're gonna take a quick review, right? Mathematics, study numbers.
Yeah. Right.
All we do with numbers is count. Highest number we count to is 9.
Right.
The crucial one that you had a little issue with is we only count stuff that's same. Right? Okay. We form rectangles to facilitate counting. That would be if we were, like I said, I gave you an option between doing problem solving and factoring. Well, if we were doing factoring, we're going to be fooling around with a rectangle. But since we're not, we're going to be doing 0, 0, and no fun, get back to 1. I just did some really, what looks like complicated algebra. And guess what? We had exactly 2 arrows in our quiver. 0, 0, and no fun, get back to 1. That's it. That's all we got. So that's all you're going to use today. All right, so I'll write you a problem. And let's start small and easy, just to remember. 3x plus 2 is the same thing as 2x, so we won't even need no fun, get back to 1, just 0, 0, plus 5.
Right.
All right, solve it. Oh, and here's what you do. Get your blocks out. First thing, blocks.
Yeah, I have them right here.
All right, well, then you get 3 of those.
Mm-hmm.
And 2 of these. And over here we got 5 of these. You see, little kids, they love this. They love coming up to the board and getting to use their eraser or whatever to take it out. And then let's see here. Let's make I'll make my equal sign red just for fun. All right. Now, here's the thing. Dude, do you see stuff on both sides the same?
Yeah.
All right. What does the equal sign say? It says same. So let's take away the stuff that's same, and then we'll figure out, right? Again, remember that these guys are always trying to trick you into thinking that they're 10. They're always trying to trick you that they're big, when actually they could be anything. Right?
Right.
Okay, so take away the stuff that's same on both sides. This is you.
Okay. Right.
Tell me what to do.
So, you mean just like taking away like 2 of the green ones?
Okay, take away 2 of the green ones. I like it. That's exactly what I mean. You're telling me though, I'm not telling you. So you took away 2 green ones over here. Can I just take away 2 from this side? I gotta take away 2 from over here too, right?
You have to take from both sides. Yeah.
Alright. Now what?
And then you take 2 of the x's.
Yeah, okay. Gotta take 2 of those and 2 of those. And I get back to the same thing as last time. X is 3.
X is 3.
Alright, so if x is 3, that means that each one of these was a 3. So 3 oh, this pen is just about mocking. But see, it lasted a long time. 3 times 3 plus 2, and over here I have 2 times 3 plus 5. And that turns out to be 11, and that turns out to be 11, just like last time, right?
Right.
Okay, this is a review. Alright, and then what I'm saying over here, and what we did is we took away 2, so your first thing you did, took away 2, and then we took away 2x, and then we took away 2x. Oops, let's be nice over here.
Right.
With my notation. And then look what I'm going to do. I'm going to make it very clear that that was a 0 and that was a 0. Good? I can tell by your face. You totally get it. All right. See? No mystery. That's why. That's no mystery. It's not magic. We're just doing math. Right? Basic algebra concepts. Okay. Now, let's get bigger. Let's get tougher. Right? Because these are all positive. The numbers are all small. We're going to get a little bigger. But not much, right? We gotta baby step our way up there. All right, so now let's do 5x plus 4 is the same thing as 3x plus, oh, you know what? We'll make this negative just to jazz it up a little bit here. Okay, so it's gotta be negative, and we'll make this, we're gonna make it big, we'll make it 8. So not too big, but, right? But see, once you understand the concepts, all I can do is change the numbers. Alright, now think about this. How am I going to make this 0? And I'm going to make this, I'm going to say 1, 2, 3, 4, 5. Right. And he's playing blocks. Now we got the whole thing going on. We got symbols, we got blocks, we got pictures. It's all happening here at the House of Math. Okay, these guys are all positive over here, so I'm going to draw 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And these guys are negative, so I'm going to make those red. What do you say? Just so I know. I could make them black, but I have a great story. And it was Brooklyn. I have a great story. So it's because the best part about this story is it's true, and I don't have one handy. Darn it. Oh well. Okay, so Jerry Mortensen, the guy that taught me math, goes to Brooklyn, and he's using black for the negative numbers and for the negative x. And of course they gave him a ration. Well, black gotta be the negative one, blah blah blah, right? Okay, so he came home, and I mean apparently they gave him quite the ration. So he came home, and instead of making these black, he sent him flesh-colored ones. Like they're kind of pinkish. I mean, literally they're flesh-colored. What we would call flesh if you were had a box of Crayola crayons.
Right.
So all the negative ones were flesh-colored, and that was the day that I knew me and that man were gonna be friends till the day he died. So he goes, fine, I didn't put black ones in, I put these flesh-colored ones in, and you guys can use those for the negatives. Does it matter? It doesn't matter. Oh my goodness. Anyway, alright, so, find me the same stuff. That story is, the best part about that story is it's true, and I have the evidence. I have flesh-colored ones around here someplace. I just don't have them handy. They're down in the car. Alright, so, tell me what to do.
Okay. We have the negative.
What's the first thing you do?
So right. So I have to find a way to get rid of the units.
Alright, so here's what I'm gonna do. Because we didn't cover this concept last time. Let's talk about zero for just a second. Let me show you a fancy way of making zero. Oh, got smudge on it. 3 and negative 3. Isn't that just a zero?
No.
What do you mean? 3 and negative 3? Isn't that zero?
Wait, no, yeah. Yeah.
Uh-oh.
3 and negative 3.
3 and negative 3. Alright, it's 0. Alright, so, wouldn't 5x and negative 5x still just be 0?
Those would be 0.
Okay, remember that for the future. So, is there a 0 hanging out over here? There's always a 0 hanging out, right? Over here, I mean, plus 0, right?
Yeah.
Okay, well, what kind of 0 is it? Well, it's going to be a 4 minus 4. Right. Now, do you see stuff that's same? So here's what I did. Over here, I put 1, 2, 3, 4. Those are the negative ones. But I can't just take, right? So there's 0. There it is. There's my 0. 4 and negative 4.
Okay, so it cancels itself out.
Right, because it's just 0. There's 4 and negative 4. That's 0.
Right.
Alright, now can you find stuff that's same? Do you see stuff that's same on both sides?
If you add...
There's no ifs. Do you or do you not see some red ones over here and some red ones over here?
Yeah, there are red on both.
Alright, so get rid of them. Boot. Boot. That's the same thing as just adding a 4, isn't it?
Yeah.
Alright, I like it. I like
Okay.
it. So here's what I did. I added 4, and then I added 4. There they are. Why did I add 4? Because 0, 0.
0, 0.
Right?
Okay.
Now what?
Then you subtract 3 from both sides.
I like it. Now I'm going to take 3 from both sides, and I take 3 from both sides. Uh-oh! What do I have here now? Okay, so you took away 3x, and you took away 3x, and when I did that, that's your other 0 that you had to get, right? I believe you called it equalizing. Okay, so now I have 2x is the same thing as 12, right? Alright, we have a problem, because I have a rectangle. Oh, let's use... I have black here, don't I? I do. Ooh, how about Harold's purple crayon? Let's go with that. I have a rectangle on this side, which is 2, and I don't know. Right? 2x? I'm just stylizing these guys that you have. Right? Instead of making it big and long and skinny. But I mean, can you see that this is 2 right here? And this is x this way, right? Okay, so that's a rectangle. Like, we use rectangles to make it easy to count. And then over here, I have the whole rectangle, and I know it's 12. Right?
Right.
There's 12 of them here. Now, here's the thing. If I know that this side has to be 2, don't I? Because the equal sign never lies. Well, if the whole rectangle is 12 and one side's 2, what's the other side have to be?
6.
Done. All right, so now I'm going to take away all the superfluous stuff. Oops, and I can put a 12 in here because I know. Right? Well, now I can take away all this stuff. And x is 6.
Right.
All right, let's do it using symbol only. And all I did is I said, look, I'm going to just line these guys up. So instead of them, let's draw it. So instead of them, here's this, and there's my equal sign. And instead of them being 4 across, I'm just going to make them 2 across. And I'm going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 1. There's 1. There's 1. There's 1. Right?
Right.
Okay. So there's a 1-to-1 correspondence.
Mm-hmm.
Okay. Get your hands on the blocks and make this.
Okay.
I'm serious. It makes a difference. Particularly with you, I can tell. Anyway, yes. You have kinesthetic tendencies. I'm not sure if that's your primary learning skill. But you know what, more easy? Just grab 6s.
Oh, yeah.
Rather, I know, you're grabbing a whole bunch of, right? Just grab 2 of these.
Yeah. Okay. Oh, I have some flesh colored ones.
There you go. See?
Yeah.
Oh, those are 7s.
Oh.
Different. I like it because there's a lot of places where that is flesh colored. But no, he made them pink, man. He made them like pink. I gotta go grab one and show you. Like they're, you know what I mean? It's like that. Like I said, in the Crayola box, there used to be a color called flesh, and that got him into all kinds of trouble because whose flesh are we talking about?
Yeah.
Yeah, because my flesh isn't that color, neither is yours. Right?
Right.
Anyway, like I said, the whole thing it does not matter, right? The outside, it's like playing skins. You play video games at all?
Yeah.
Okay, so the skin can be like the most fearsome, awesome skin, but if the kid's like crappy, he can't play, it doesn't matter what the skin is, does it? Yeah. On the other hand, the guy can be a full-on expert, and his skin is you know, totally lame and basic, but he'll kick butt, right? Because the skin doesn't matter. The husk is just the husk. It's what's inside, the character, the quality of your content, the quality of your character and content of your character. Is it good or is it bad? And guess what? See, this is the thing. We're all programmed to think, well, you know, certain people are more good than bad. No, I don't care who you are, what your race is, what your sex is. There's good and bad people. Right? I've met some people, I mean, I've met lesbian white girls that were racist AF. You know what I mean? Just because they're lesbians doesn't make them cool, right? They're still racist. I met, and then on the other hand, I've met, you know, white guys down, totally couldn't care less.
Yeah.
And then up there in Idaho, my favorite one is, I'm not racist, I just don't want my daughter dating a black guy. That kind of sort of makes you racist. Sorry. Right? They're so racist, they don't know they're racist. But anyway, the idea is that color doesn't matter. It does not matter. I mean, we got to get past that part, for Pete's sakes. And in New York, that's lovely because you got the full melting pot. That was one of my favorite things in New York. And back then, I went to Times Square. It wasn't the cool Times Square it is now. Times Square was this whole other animal. And it was freaking awesome to just sit down there and watch the humans go by. It was a zoo. Every kind of human you can imagine. Right? From like pitch black skin to pale white blonde, you know what I mean? And every shade in between. We are an interesting race of humans. I mean, humans are pretty cool because we're so diverse. Yeah. Anyway, all right, let's get back to this. The idea being here is that, look, all I did is say that 2x was the same thing as 12, and then I just divided out 2. Right? No fun. Get back to 1. That's it.
Right.
Easy? Alright. Alright, now I think you can go to town without any help from me. Well, we're about to find out, but but we'll see. Alright, so here's it momentarily. Yes, the moment of truth. You are on your own. Alright. 5. Oh, let's make it bigger. You're a big boy now. Let's go with 7x plus 8 is the same thing as... Oh, we won't go to fractions quite yet because you're not a happy fractions guy. We got to spend some time on fractions. So we're going to keep the numbers whole. But can you see I could teach you fractions doing this? When we're going to get there.
Yeah.
Right? Because if I had a fraction, then you'd have to multiply your fractions in here. Well, let's make it a simple fraction this time. I'll tell you what. I'm so good I can do that. We're going to go with 5x, and we'll make this... we'll make this 9 over here.
Okay.
You're on.
So,
I don't want... You just go. Get your blocks out, or get a drawing of it.
Okay.
And go. Write the problem down in your notebook.
Okay.
Yeah.
Okay. So I have to. I don't know if.
Yes, you do. No. All you gotta do is 0, 0. No fun. Get back to 1.
Here is it. Right. Okay.
Get rid of that. Get rid of that. Get going.
Right. The only problem I see is that if there's no, oh wait, no, what am I talking about? It's minus 8
Yes.
on both sides.
Yes.
Yeah.
Yeah.
You got 7x equals 5x plus 1.
I like it.
And then you gotta do minus 5x.
There you go. Alright, so I'm skipping all that. So here's what you did. I like it, I like it. You did the minus 8, and then you did the minus 5, and then you wind up with a 0, and another 0, and then over here, I'm going to wind up with, oops, I forgot the minus 8, and now, oh yeah, I forgot the minus 5 too, I'm being silly. Okay, and now you got to the point where you said 2x is the same thing as 1.
Right.
So what's x got to be?
X has to be 1.
2 times 1 is 2.
Right.
2 times what is 1?
2 times 1.
2 times 1 is...
Oh no, that's 2.
Yeah, it's 2. So what do I have to... See, I told you, I made it a fraction.
Oh, right. So 1/2.
There you go. See, we baby stepped our way up. And now x has got to be the same thing as a half. Why? Because no fun, get back to 1. Right?
Right, yeah.
Okay, so x is a half. Oh, now what? Now I'm saying 7 times a half plus 8 is the same thing as 5 times a half plus 9. What's my 2 numbers? What's a half of 7?
Say that again.
What?
Half 7. 3.5.
3.5 plus 8 is?
11.5.
11.5. I like it. 11.5. This side better be 11.5.
Yeah.
What's a half of 5? 5 times a half?
3.5. No, 2.5.
2.5 plus 9 is 11.5. Oh, and I shouldn't use 0.5. Let's since we're doing fractions.
Okay.
Right? So I snuck a little fractions in on you, just to get you warmed up. We're gonna not today, but next Monday, I suppose it should be. Come on Monday. We'll do a whole hour just fooling around with fractions. Because that you can't go through life not being able to do fractions.
Yeah.
Yeah. All right. And anyway. Do you see now though that this is easy?
Yeah.
Because what are they doing? They're giving you all these rules, and you couldn't remember how the rules worked, and then you wound up having a hard time, right? But now all you're seeing is, what are we doing? We're finding stuff that's same on both sides. I didn't even draw pictures on this one. You did it all by yourselves. Right? But I can look at that, and I can see, oh, same, same. I can look at this and say, same, same. People are like, how do you make these problems up on the fly? Well, because I'm in my mind, and what do I want to do? I want to do fractions with you. All right, so I didn't want to get some crazy fraction. Let's just do a half. The difference between this and this is 1. The difference between this is 2. So I was going to come up with a half. See?
Right.
That's more of an explanation for any tutors that are watching this in the future, but, you know, that's the idea. right?
Okay.
And then, because look, first principle, mentalism. The blocks are what we say they are, right?
Right.
So this is an X. No, it's just a piece of plastic, but no, I'm calling it an X. And not only that, now I'm saying, oh, this X isn't even a whole number, it's a half. Right?
Right. Mm-hmm.
And I had 7 of these halves. Okay, and again, the only time this statement is true is when X is a half. If you came up with X is 1, well, that would be 15 is equal to 14. That doesn't work. If you said X is 2, well, certainly that's not going to work because that's 14 plus 8 and 10 plus... That's not the same number. But when it's a half, oh, these are the same number. These are just numbers in disguise. And you're discovering what the number is. That's why you'll make me crazy if you go take a test or you take an SAT and you say, I don't know how well, you don't know how well you did. Did it equal each other or not? Right? So there's no way to fail. This is why we love the math, right? And see, there's the other reason why I used to like math over, say, English. I was just talking to this other kid about English and so forth. The teacher likes you, you get a higher grade. The teacher doesn't like you, you get a lower grade. In mathematics, you put 11, right? You get X as a half. They like you or they don't like you. It's right. Right? And then they try to give them some wiggle room with this whole Common Core thing. I'm not even going to go down that road where it's like, oh, if you don't do it the way they say, if you decided to take away the 8 first and not the 5x first, then they take points out or something, right? Oh my God.
Yeah.
No. However you do it is however, right? As long as you get to here.
Mm-hmm.
All right. Let's get crazy. I'm going to give you like 3. And then you can just work.
Okay.
And it's actually so I can go make tea. But anyway.
Okay.
But I'm going to give you like 3 problems. And I'll tell you that every one of these is just going to come out even. Or just come out a whole number. All right. You ready to get down?
Yeah.
All right. Well, let's be negative. Oh, that's here. Let's be positive over here. And we'll go with, okay, 6. And then I'll say 5x over here. And we'll make this negative. And we'll make it 30. And then over here, I'm going to go with 7x minus 8 is the same thing as 4x. And we'll make this 19. And then we'll do one more just for fun. We'll do like 12x. Plus 6 is the same thing as 7x. And actually, you know what? We'll make this minus 35. We'll make this oh, let's not. Let's make this 3. And then we'll make this just a 2 so it looks cool.
Got it.
Alright, got all 3 of them?
Yep.
Okay, go to town. Tell them what the answers are.
Yep.
You can check them now, so you know if you got them right or not. So, I mean, we're at the point where basically I become superfluous. You don't need me anymore. You can just do it, right? Alright, but go.
Okay. Okay.
And see, in less than an hour. And we'll come back to it because one lesson does not make you a pro, right?
Yep.
Yeah, I have a student, he's very naughty. He was supposed to go watch a bunch of videos and he didn't do any of it.
Oh.
So you gotta go, when I give you homework and when I give you passwords, go just watch the videos. So far you managed to watch 1?
I watched the hour-long overview.
Oh, excellent. Excellent. When you watch those, you gotta put them on double speed or something. Or, you know,
yeah.
1.5 times speed because that should have been total review for you.
Yeah.
But good, you got it a second time. Good. And you got it a second time a different way, right?
Mm-hmm.
And then you're going to see lots of videos of me fooling around with other kids doing this kind of stuff.
Since equals 2x. So it's 6x. 6.
Oh my gosh, so much stuff.
But the thing is, it is. That's the beauty of it. It is real. It's not
Yeah. Negative 12. So right, and then I could check it by doing the.
All right, what would you do the first? Okay, tell me the first one. What'd you do?
So I subtracted 6 from both sides.
Got it. Then what?
Then I got rid of 5x on both sides.
I like that.
And then after that, I divided 6 from both sides.
Now here, just for fun. Yes, there you go. I like it. So you had, what you wound up with was 6x is the same thing as 36, right?
Right, but I had it at...
Oh, negative 36, by the way.
Okay.
And what'd you say, but what?
No, that's how it was.
Okay, there you go. Okay, so now what? That's no fun.
Right, then I said to divide it by 6 on both sides.
There you have to. And x is the same thing as?
12. Negative 12.
Are you... What?
Isn't it negative 12?
How many 6s in 36? You fumbled on the 1 yard line! Oh no!
Oh no. No, it's negative 6.
There you go.
No. I was thinking of 3s.
Yeah. Oh yeah, okay. There you go. Okay, yeah, if it was 3 it would be 12, but it's not 12, it's 6. Alright. So now, and then here, I'm just going to show you one more thing just for fun. Isn't there negative 5x plus 5x over here? So then when I find the stuff that's same, right?
Yeah.
It's the same, right? Now, why go through all of that with your hero 0 when you can just shorthand it? Right? But that's actually what you're doing. Just remember the identity. Every number. Right?
Every number.
Every number we can add 0.
Right.
And when we add 0 to a number, does anything change?
No.
Why, no. But sometimes I'm adding a 0 and it's a 6 minus 6. Sometimes I'm adding a 0 and it's a negative 5 minus, or excuse me, a 5x minus 5x. Which is where you say, there's a saying in mathematics, sometimes you need to know how big your 0 is. Right? But I mean, there's always a 0 hanging around, and he's your hero, because he will help you. And 0 is impervious. If I multiply him by anything, it's still 0. If I divide him by anything, it's still 0.
It's 0.
We love hero 0. Alright. First one, you got it correct. Oh, what's the 2 numbers?
What do you mean, what are the 2 numbers?
Just what I said?
Oh, so 11...
Times 6 is?
11 times 6 is 66, and then on the right side you would have 30x.
Well, wait a minute here. We have a problem. Houston, we have a problem. Is that what I started off with?
Okay, well you have 11x, and then you have 5x.
Oh, but it's negative 6. Okay. Yes.
Oh, negative 6. Gotcha.
Yes.
Okay, so it would be negative 66, and then negative 30.
So wait a minute. So hold on.
Wait.
It would be negative 66 plus 6, and over here it would be negative 30 minus
negative
30.
Minus 30.
So what's the number?
Right. So
the number is negative what?
So on the left it would be negative 60.
Mm-hmm.
Oh no.
Yeah.
Yeah, it would. Yeah. And then on the right it would be your negative 60.
It better be, because it says they're equal.
Yeah.
So if it's negative 60 over here, it better be negative 60 over there.
Yeah, no, I was just...
Yeah. That's why we're doing it. Exactly. Now, what you just did is you evaluated this expression for x. And x turned out to be -6.
Right.
All right, next one. Fine job.
So this one would be...
And see, this is how fast it happened. You're 16, right? If you were 5 or 6 or 7, we'd still be playing with blocks. But see, we went from blocks to drawings to symbols like that because you get it, right? And if you didn't get it, see, I'm looking at you. If you didn't get it, I would be able to tell by looking at your face. And then, you know, but we can whip through this because you already had this and you just had some misnomers, some miscalculations, some, right? Some. And again, whose fault is that? Is that your fault or is it the people that were teaching you?
The people who were teaching me.
Yeah, how popular does that make me with the people that are teaching you? Right? Because they don't want to hear it. See, and they've turned against us. These teachers have. Anyway, it's a long story, but basically, they won't take responsibility, so they blame you. It's the student. They've got dyscalculia. They've got ADHD. They've got broken homes. They've got whatever the hell it is. We can't teach them. Oh no, they never say we can't teach them. It's that they can't learn. They don't get breakfast. I mean, whatever they can come up with. You should get breakfast. You should definitely eat before you, I mean, don't eat so much that you're tired when you come to class, but eat some food that gives you some energy before you come to class. Because you know what? You're working the muscle that uses the most calories is your brain. Right? When you run your brain, that's why a lot of times, like for me, not taxing until I get to calculus, and it starts to get taxing a little bit. But I mean, for little kids and for right after they do an hour of math, sometimes they need a nap. Because they burned all those calories. Because they were thinking.
Yeah.
Are you ready? You got the next one?
Almost.
Okay.
Just about to get it. So this would be...
You drink coffee?
Not a lot. Sometimes I do when I'm really tired, but usually I don't.
I was going to say, the caffeine, probably want to skip the caffeine before class.
I only drink caffeine when it's, like, necessary.
Right.
Like,
early in the morning when you got to get up and do something?
If it's, like, a road trip or something.
Right.
Usually when I'm traveling, that's usually when I take coffee.
There you go. Do you drive?
No, not yet.
No.
Okay, so it's plus 26. Oh, wait, I wrote that down.
Yeah, we got to, my boy, I cannot believe it. We're sitting there thinking, all right, because he's about to turn 15, and in this state, at 15, you can get a license, right? Back in my day, at 14 and a half, I had a work permit license because this used to be a very agrarian society,
right.
And they would give us licenses so that you could go drive to work in the pineapple fields. And then, of course, we used to abuse the hell out of the license because it was only supposed to be for work, and you weren't supposed to drive at night and all this other stuff, right? But and then after you had a 6 months grace if you didn't get in trouble, you didn't get a ticket, or you didn't get in an accident or anything, then they'd give you a full license without restrictions at 15. And so by the time I was 15, I'd already been driving for 6 months, because as soon as I was 14 and a half, I got the license. My mom did not want to have to drive me everywhere, right? Especially not to work and back. So anyway,
Yeah.
Now
you have to be at least 16 to get a permit.
There you go. And over here, you have to be at least 15, and you have to have, like, I can't remember, the driver's education course that costs like $500 between 15 and 18, and you have to pass it with you have to. Not just
with flying colors.
With flying, exactly. You can't get like a D, right? You gotta pass it.
Right. Okay, so I think I'm in a bit of a situation here.
Oh, so you are in no situation?
All right, so I added 8 on both sides.
I like that. That's number one. Is the first thing to do is add the 8.
Yeah.
Add the 8. Then what?
Then I subtracted 4x.
All right. What's the problem?
So then I get to 3x equals 26.
You do not.
Well, because I...
Is 19 and 8 26?
Oh.
Yeah, see, that's the stuff that used to kill me. All right, see, and now we got the little boy in the back of your head. Did they used to tell you were bad at math when you were small?
I wasn't very good with quick math, is what they would say.
Okay, so that's your subconscious mind telling you, well, you can't just add a 19 and an 8 and get the right answer, because that would make you, right?
27.
There you go.
Alright.
And even if it was 26, who cares? You still could have done it. But it's not 26, it's 27. So what's x?
27. So then it's x equals 9.
Got it. And now we got to go back and put it in.
Right.
So 4 times 9 is 36 plus 19. And 7 times 9 is 63 minus 8. Same number.
Right.
Alright. Which is going to be 55 equals 55, isn't it? Alright.
Yeah, well, the 7x
That's what it is. It's 55 equals 55. So let's check it just to make sure. 7 times 9 is 63. Minus 8 is?
That would be 51.
I have a severe problem with that answer.
Yeah. Oh, gosh. No, I was thinking...
Alright, here's what I'm doing.
I was thinking of 12. No, I was thinking...
Okay, there you go. I'm giving you supremely simple subtraction. Is coming your way pretty quickly.
55.
55 is the correct answer. And then over here I've got 36 plus 19, and that's also 55.
55. Okay.
Right, and now do you see where when we got little kids, we can do fractions. We can practice our multiplication tables. We practice our addition and subtraction, right? We practice making zeros.
Right.
Okay.
Right.
All right. And here's what I'm going to say to you. I wasn't joking when I said, look, you can get $50 an hour. Right? Well, not tomorrow, but I mean, you could start off where go find yourself. Are there any 6 and 7-year-olds in your neighborhood?
Yeah.
Yeah, that's what I mean. Within walking distance, there are thousands of 6 and 7-year-olds. All right.
Yeah.
So go put a flyer out once you get comfortable and say, look, I'm going to do a little class for kids, teaching you how to use, then you got to use the buzzwords, multi-century mathematics using manipulatives. And the parents will go, oh my God, multi-century mathematics with manipulatives? I got to have some of that. And then you can teach them, because can you see any 5-year-old kid can do this? Not as fast. Yeah. But I mean, what are they doing? They're going to grab some from this, right? They're going to take 4x away from this side, and they're going to take 4x away from this side. Then they're going to take away 8 from this side, and they're going to take away 8 from that side. And then they're going to count what's left. And then they got to divide the 27 into 3 equal groups, right?
Right.
So they ain't getting through this in, lickety-split like we are. Right? You might get, in an hour, you might get, let's say 5 minutes a problem, you might get 12 problems done. And then the other thing, I'll show you, and I have all manner of stuff on my website about teacher training and so forth, is that for you, I'm going to do that, because you're 16, we've got an attention span that's long enough, right? Or should be. Okay. Well, then we can spend an hour just doing this one thing. But if you're working with little kids, you do a few of these problems, then you do some fractions, then you do some addition, then you do subtraction, then you do some factoring, then you just, right? Then you fool around with square numbers, then you build, and then you just play around and build stuff and count that, and just, right? So that an hour goes by like that, and then you get paid. Right? My son has to work 3 hours for what I make in 1 hour. And he still doesn't make the same. He's still $5 short when he's done, because he makes $15 an hour. Right? Pushing a lawnmower around and doing yard work and cutting cane grass and yucky work, but $15 an hour is $15 an hour. Right? Okay, it takes him 3 hours to make $50. And he's outside working. I'm sitting here on my butt in the inside, right?
Teaching math.
Teaching math. There you go. Right? Okay, anyway. All right. Next one.
Okay.
But my idea is that as you go forward, like I said, in the next little while, dude, every dollar that you spent in tutoring, or that your mom has spent, or whoever's paying for this, you can make it back in spades. Especially since you already have a kit over there. Those blocks can turn into cash quickly.
Yeah.
And now here's the other thing. What if you only work 1 hour a week? That's actually $50 a week.
Still 50.
Still $50, right? And the way you could do it is, okay, you don't feel confident charging $50. So, okay, so you get 4 kids and you charge each one of them $15.
Right.
Or $10. Right, keep it even. 5, 10, 15, 20. Those are the 25, 50. Right?
Right.
And then I do 60. I have plenty of the people that I've taught charge more than I do. Right? They charge like 75, 60, 75. Someone charged 90. Because one lady, she's charging $122 a minute. She charges, and she gets it. She's in Los Angeles. Right? And I don't charge $120 an hour, but I could if I wanted to. I mean, I taught her, for Pete's sakes, and sometimes sometimes I catch her doing things that dismay me, but it's all right. Like, her clients don't know.
Right.
But there's a way to do this. You can't just do what you want.
Oh, hang on.
Oh, this one should be fun.
So it turns into.
Turns into, I love it. Yeah, yeah.
It's a 5x equals 0.
It is not. There's a 2 over here. This is negative 33.
No, I got the 2, right, and I subtracted the 2 to put it on the other side.
Well, then I would go the other way, sir.
Oh, to the other.
Well, I mean, you can, but then what are you going to have? You're going to have everything on this side. You're going to have 5x minus 35 is the same thing as 0. How does that help?
Right.
So remember, Will, the name of the game is some x, I don't care which side, but some x on one side and some units on the other side. Okay, write that down in your notes. You want x on one side and units on the other side.
X on one side.
And I don't care. The x could be on this side or it could be on this side. But you don't want x and units on one side, because that ain't no fun. And if that's what happens, then you need 0, 0, or no fun, get back to 1, one or the other. But, well, in this case, it would be 0, 0. So why not just add?
Plus 33.
Yeah. And then what do you got?
So, right. So then...
Look, we skipped all the steps.
So then that becomes... Right, okay, 1 second.
Yep. Lots of scribble and scratch. All right, and then here's the other thing I'll tell you, what I tell all my students. All right, you're doing these problems? Put notes. In English, not in math. In English, put some notes. Look, here's where I did hero 0. Here's where I did hero 0. Here's where I did no fun, get back to 1. Right? Then I evaluate the same problem for the negative value, right? So I had negative 6 goes in there, 11 times negative, right? Okay, same thing over here. Then I figured out, what did we figure out over here? Oh, we didn't even do the rest of the math over here. What did we figure out that x was?
We found out x was...
Oh, yes, we did. X was 9.
Yeah, 9.
Okay. And now over here, we're figuring out that x is?
After we do the math, it's 7.
Yes, there you go. After we do. And what math did we do? We just did no fun, get back to 1.
Right.
7 times 7 is 49, plus 2 is 51. 12 times 7 is 51. No, 12 times 7 is 84, minus 33 is 51. Okay, so 51 equals 51. We got them all. Oh, look, our hour is up, but we start a little late, so we can go a few more minutes. All right, let's fool around with, like I said, enough of this, and we'll come back to it. Now you know what? Now your subconscious mind is going to fool around with this. Right? Now your subconscious mind is going to go, oh, and that's why you want the blocks to start off with, because the subconscious mind does not hold symbol. Right? The subconscious mind thinks in pictures, and we have been given a language that does not know how to interpret those pictures. So when you have a dream, half the time you don't know what the heck your subconscious mind is trying to tell you. But if you wake up with that dream firmly in your head, people have figured out that sometimes you can interpret those dreams, and they've made all kind of inventions and devices and wrote poetry and stories and so forth, because your subconscious mind is always active. It never goes to sleep. Right? Only your conscious mind goes down. So your subconscious mind is now going to be like, okay, this is cool, we can figure this out, right? And start fooling around. But they can't do this, it can't do this. That's why you got to put symbols in there. Or excuse me, drawings. Right?
Right.
Or confuse the term. And then the other thing, you got, and if you have the manipulatives, now you've actually added more senses. Your hands have gotten on it, right? So now your brain can manipulate these things, right? Instead of just looking at symbols.
Yeah.
Right? Okay. It's like when you look at a picture, or like when I used to sit in, like I said, a couple of places I love to sit. Ala Moana Center is another place I love to sit and just watch the humans go by, because it's a huge shopping center on Oahu, and everybody goes to Ala Moana Center eventually, right? And it's great because being from Hawaii, if I sit in Ala Moana Center long enough, I'll see people that I know. Right, and it used to crack me up because I'd see people that I grew up with from in a small town called Waihehe. Don't see them here on Maui, but I see them at Ala Moana Center, right, on another island. Okay, but I mean, the point being is that when people walk by, I make up stories, right? Because I see pictures and I see that, right, and I'm like, oh, you know, you see, like, you know, I remember an older couple and they were dressed to the nines, and I made up a whole story about, you know, they were visiting royalty or something like that, and they were trying to be incognito and so on, right? But I mean, you know, you just make up stuff. Okay, your subconscious mind does the same thing. It makes up stories to make sense of what it sees out here in the physical world. So we just made up, right, we got 0, we got no fungi back to 1. We got very simple concepts that your subconscious mind can deal with. And then the next time you see this, it's going to be super easy. And then the third time you see this, you're going to be like, okay, we got this, let's do something else. Promise. I've been doing this a little while. Alright, now let's fool around with some factoring.
Okay.
We'll start off with this super easy basic one that we start off with every time, right? You know how to do that one, right? Because you watch you've come to class and you watch my thing. All right, so bust it into, do it. Get your blocks out and throw it together super fast.
Yeah. Okay.
Bam.
So you get the.
Bam.
Right. You get the 100.
Right.
You get.
And let's remember, yours isn't smooth, but we're just pretending it is, right?
Right.
So yeah, I got a dark one. I need a flesh one. I gotta get a flesh one. Here's the one that they were complaining about. Can you see the difference?
Yeah.
Right. Anyway, and then I gotta go.
That looks like an indigo.
Yeah, there you go. But before this, there were ones that were actually like dark. I mean, they were black. But anyway, the point being is that I gotta get one that's flesh colored, just because. And it's true. It was in Brooklyn. It was Brooklyn that happened.
Oh.
So there are schools around you that have these blocks. They're probably hiding on a shelf someplace in the back closet or something.
You don't talk about them.
Yes, exactly. We don't talk about it. We don't use them. Because what happened is that, well, what happens is, all right, so let's say I have a group of teachers that we trained in the 1990s. All right, none of them teachers are left. And they don't pass the knowledge on to the next group of teachers. The new teachers come in and there's no, see, the whole sacred trust has been destroyed by these people, and I'm not even going to go down that road. But anyway, they right? Because there's 3 trusts. There's only 3 trusts. And there's 3 sacred trusts. Teaching, healing, ruling. Right? And if you do teaching, you don't need to heal, because they don't need healing if they know how to eat and how to take care of themselves. Right? And then ruling. You don't need rule if you've been taught well and you know how to govern yourself, and you know you don't need to steal, and you understand that anyway, you don't need much ruling. But teaching is the primary sacred trust, because that's how we pass on knowledge. Right. Now we got these rulers in control, and they have completely turned everything upside down when it comes to healing and teaching. Right. The healers aren't healing, the teachers aren't teaching. Right. There's only one group of people, or that does that, the deceivers, and we'll leave it at that. Right. They're not the tellers of truth. They're the tellers of lies. All right. What are the factors?
So then you have... Okay, just one question about this.
Yes.
Is putting the 2x on the top just preference, or is there...
It's preference, exactly. Does it matter? You could build it like this if you wanted to. It's the same rectangle.
Right.
I mean, you built a cool rectangle. Your rectangle was super cool. I liked your rectangle the best. But it's just hard to count. I mean, it's still a rectangle. That's how you built it, right? When you first started out. Okay. It's just harder to count. But I can still see that this is X and 1 across, and X and 2, right? Or technically it's 1 plus an X plus another 1, which is X plus 2. right? But if I build it like this, it's just easier to see.
Yep.
Okay, so the only thing is when you write it, it is important to know that your blocks and symbols match. So that's the across, that's the second factor. This is the, technically, the first one is the multiplicand, and the second one is the multiplier. The thing that you're multiplying the number of times, right? So when I have something like 3x, the multiplicand is constant, the x is what's varying, the multiplier varies, right? Okay. And that's hugely important. We even lost that much. I have arguments with math teachers about which one. It's multiplication. I'm just gonna put this and I'll make it the it's
three. It can say 3 multiplied by.
Right there you go. But it's multiplicand, multiplier, right?
Mm-hmm.
Product. Da, 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 right? And then over here, it's going to be dividend, divisor, ND, and over here, it's going to be quotient. There is no argument because we can't you can't swap these two, right? Over here, you can swap them because 3 times 2 and 2 times 3 are the same thing. So they're thinking that, oh, it doesn't matter which one's the multiplicand and which one's the multiplier. I'm sorry, yes it does. Syntax is important. Right? And this is why so many of your programs screw up, because a lot of coders don't understand that this is the thing multiplied and this is the multiplier.
Right.
And it matters.
Anyway. Does it matter like all the time, or is it just like...
All the time. It never not matters. But for little kids, 2 times 3 and 3 times 2 is the same thing. But if we're talking about, let's say, if I have, let's just really, okay, we got the time. If I got 2 kids, and each one has 3 marbles, that's not the way to write that. It's 3 marbles taken 2 times gives me 6 marbles, not 6 kids.
Right.
Right?
Yeah.
So the marbles is the thing being multiplied.
Right.
Now if I have 12 of these, then now I've got 36 marbles. I don't have 36 kids.
Right. Context.
Right? So, multiplicand, the thing being multiplied, is marbles. The multiplier is the number of children I have that have those 3 marbles. And my product is that, right? And now we can say, oh look, this is a rectangle, right? These are the sides. That's 3 taken 12 times, and the whole thing is 36.
Right.
Then I can turn it on its ear, and I can say, well, if the whole thing's 36 and one side's 12, the other side has to be 3.
Right.
They are inverse functions.
Mm-hmm.
All right. Let's get bigger over here. X squared, 4x and 3. And we'll go, if my next student doesn't come, or, which may be the case, they usually call me though, or they might come at 1 though. I have this one student, will remain nameless, they pay me 100 lessons in advance.
Mm-hmm.
So, I can't really gripe and moan if they don't show up, right? Because I've already been paid, and I just keep the money if they don't. If they don't come, I just keep the money, right?
Right.
But it's annoying because then I schedule my life around those hours, and then they just don't come, and I could have had you, or I could have had somebody else, right?
Mm-hmm.
Or I'll be someplace else, and I'll be rushing back to get home, and then they don't, right? But boom, $50 anyway.
Right. Mm-hmm.
But it's very annoying, and you have 1 strike, sir. You already have 1 strike.
Yeah.
Just saying. Just call the night before, right?
Yeah. No.
And then I don't have to. Then I don't have to.
It's that
Yeah.
Yeah. No. It came out of nowhere.
Yeah. There you go. I get it.
It started right on Sunday.
Yeah. And then everybody's all concerned because the coronavirus and stuff, right? Everybody that's sick.
Yeah, no, we had to make sure.
Yeah, there you go. And see, and here in Hawaii, we've got stupidity going on, but yeah, we've got Chinese passengers getting off planes. Because you know what? The viruses, they like to travel. They want to come and see Hawaii just like you do. But they can't get here by themselves, so they got to climb on board you, and then you climb on board the plane.
Yeah.
And then, the stewardess gets sick, or the person, exactly, and then or somebody at the hotel gets sick, and then they work at the hotel, and then they got kids at school, they go home to their kids get sick, and then the kids take it to school, and oh my God, the teachers in this state really just, their immune system is constantly under attack.
Yeah. The funny thing is that when I went to the doctor, turns out it's just like a really bad fever.
There you go.
But when I went, all that happened is that he started nagging me about not having a flu shot.
Yeah.
And
did you tell him?
I was.
Pardon me, I don't want a flu shot.
Yeah. No. Basically, he made this analogy about like how, because we use homeopathic stuff.
There you go. And if you don't get a flu shot, I don't make any money. That's what he's saying.
Yeah. No. Actually, the homeopathic stuff like that I had works wonders. But anyway, like he was saying, he made this one analogy. It was so weird. It was like, if I fight, then I won't have to work out, or something like that.
Mm-hmm.
Like, in that sense, then then we just left.
Yeah.
All he basically said was to take medicine.
Yeah. Well, that's what they do.
Yeah.
They're sellers of medicine. That's what I mean. Our healers have become healers for profit.
Yeah.
And once you put the profit in there, right, because it was supposed to be a sacred trust, you went into healing, you knew what you were getting, right? You may or may not get paid. Right? Same thing with teaching. You go into teaching, there's plenty of times when overall, I don't deal with those, but there's plenty of times when you teach for free.
Mm-hmm.
Right? And that's part of the deal. Now, if you do all your teaching for free, you ain't teaching for very long. If you do all your healing for free, you're not healing for very long because you got to eat.
Right.
But these guys have turned it into this whole other thing, which is not correct.
Right.
When your doctor's pushing stuff on you that you don't need, and I see it all the time. I got other kids, they're pushing drugs on them because the kid has ADD and we can't teach him math. Well, here's some drugs, that'll fix that. No, it won't. And that brain is still developing. You don't want to dump potent psychotropics on developing brains. That just seems to be common sense to me, but apparently not. Anyway, back to math. Give me a factor. Give me a thing here.
Right. So it's x plus 1
Got it.
times x plus 3.
All right. See, now, would I be a complete jackass if I was like, no, it's not. It's x plus 3 times x plus 1 because I want it in descending order. I want the bigger number in front. Really? No.
That's what would happen.
Yes, I know. And it's ridiculous.
Yeah.
All right.
So it was like, well, we can't change the problem. Like, what is the solution? What are the options? What can we do here? And so she did for...
All right. 2 more. Knock them out. And then we'll call it a day.
Okay. So it's... hang on.
Build it.
My screen keeps coming up, so I can't see the screen. Hang on. There you go. I fixed it. Okay. So x squared, and then 6x, so 1, 2, 3, 4...
Oh, wait. X squared plus 5x plus 6 first.
Oh, 5x. Okay.
Yeah.
So that's just 1. So it's the same thing, but you have, you add 1 to the second one. So it's x plus 4. So it's x plus 1 times x. Oh, it's a 6. Yeah, you're bad. Okay. So that, I don't know what it is. Right. So you have 5x, 1, 2, 3, 4, 5. And then you need 6 of the little things. Where do you...
I love it.
Okay.
How are we gonna get 6 in there?
Hey,
I'm gonna tell you. I'll tell you what. I'll give you a hint. If you're trying to use a 6 like this, you're gonna have a bad time.
Yeah, no, I'm using the little units.
Okay,
but
then you should be fine.
How they fit in here.
Well, fool around with it until you do. And now, okay, so I'm gonna tell you on this one. it's only going to be 2 sides ever. Right? We're not going to use 3 sides.
I see it. I see it.
Bam, see?
I see it now.
Ooh.
Yeah, you have to make like a little 6 cube. Like.
Yeah, there you go. You got to make a space for the 6s to fit in there.
Yeah.
So what did you do?
Yeah. Okay, I see.
Yeah, let me see your blocks. Tilt your camera down just so I can see.
Oh, yeah.
Yeah, she's all showing me the blocks. I want to see the actual thing.
Yeah.
All right, there you go. Fine. So you put 3 on top. All right. Beauty.
So, go.
So what are my factors?
There we go. Okay, so you have x plus 2 times x plus 3.
I like it.
And then you want me to do the third one?
Yes, I do.
Okay.
Nah, I just put it there for good luck. You can skip it if you want to.
Decoration.
Yeah, decoration. There you go.
Yeah. Okay. And then you have to add 3 extra because you have a new slot.
Yeah.
Okay. So then it's x plus 3 by x plus 3.
All right. So how am I going to write that?
So x plus 3 squared.
I like it. See, you already knew. Because I'm lazy. I'm a mathematician. I'm not writing that twice. I'm just doing that.
And then it's one big square.
There you go. And it's a square. Exactly. This is a square number. That's why we call it squaring. And everybody's like, why is it squaring when that's a 2? And why are they called quadratics when there's only 3 parts?
Right.
Well, they're not 3 parts. There's 4 parts. Yep. And did you see the 4 parts of your quadratic?
Yeah.
1, 2, 3, 4. This is 2 parts. It's not 1 part. Dude, I've had high school math teachers that have been teaching math for like 10 years ask me, why are they called quadratics? Okay, that should scare the pants off of you. Like I said, you go out and learn this thing, go to my website, go through some of the training. I'm telling you, you make a difference in your little area. And you'll get paid well. And. You'll make and how can you possibly teach math without learning math?
I will tell you right now, I have never thought of it as an actual square.
Yeah, of course not.
Thought of it as like the physical numbers.
Right,
like
because that's what I mean. And the symbols hold nothing. This is what they're trying to represent. Right? The symbols represent reality numerically.
Right.
Right? Just like words represent reality. Right? Using pictures in your mind. Like here, we'll just do this. Close your eyes. And here's the beautiful thing about it. Close your eyes. So imagine a lemon. Big, yellow, beautiful, lemon-shaped lemon. Like, my lemons are all kind of roundish, but I mean, lemons have a particular shape.
Right.
All right, so now, I'm just using words. And can you smell that lemon? You know what a lemon smells like, right?
Yep.
Okay, so now you're going to take a knife in your hand, a nice knife. And see, I don't know what kind of knife you pick in your mind. My knife has a black handle and it's silver, but I mean, yours might have a brown handle or a wood handle. Who knows? Anyway, so you pick up a knife, cut your lemon in half. Oh, now you can smell it, and right, because when you cut open a lemon, lemons smell like lemons, and there maybe there's a little juice there. All right, now can you picture that in your mind? You can see the seeds there and stuff like that. Okay, now cut that half in half, and now you got a quarter of a lemon. Now pick that lemon up and put it next to your lips and take a bite. Oh, is your mouth salivating? Right, because your brain was picturing a lemon that isn't there, but your mouth was getting ready for that acid, so extra saliva. All right. That's the power of words. Yeah. Right? I basically just cast a spell at you where you made saliva in your mouth. Right? Anyway, but the idea being is that it's, right, words just describe reality, right? And then like I could say, close your eyes, picture a cow in a field with a fence, with a barn.
Right.
Okay.
Yeah.
Right? Okay. Your cow in a field with a barn is probably not the same. I mean, is your cow black and white, or is it brown, or is it, you know, or is it a red cow? Who knows? Right? Is it a white fence, or is it a barbed wire fence? Is the barn white and red, or is it a brown barn, or maybe it's a gray barn, and maybe it's a metal barn, because you know what I mean? But so the words, the words can have an infinite number of meanings for each one. But mathematics, 6 means 6. Right?
Right.
This many. Yeah. Right? It doesn't mean, right? That's all it is. 6 is always 6. Or it can be the opposite of 6. Right? We love numbers because they're precise. My 6 and your 6 are the same. Now, here's the thing. Here's a uniform way to visualize 6. So uniform methodology for the visualization of mathematics. That's a 6. But I mean, you could have 6 green ones. You could have a 5 and a 1. You could have a 4 and a 2. You could have a 3 and a 3. That's still 6. But the idea is it's 6. Right?
6.
Constancy.
Right.
Anyway, all right. Your homework is to go watch more videos. Go to Crewton Ramone's No Mystery Theater, and you can watch a little bit of that if you want to. Like I said, and for some of them, you may want to double the speed because they're slow, and I'm working with little kids, and for you, that's going to be painful because you're going to see the answers and so forth, so you can pick up the speed. On the other hand, if you go too fast, then it's not. I mean, I'm not going to tell you how. You'll figure it out for each video.
Right. Yeah, I can figure it out.
Yeah. All right. So the idea is between now and Monday again, right? It's supposed to be Monday. Just watch a bunch of videos on my website. And then if you have stuff, do you have a textbook or a book that you were working in or homework or whatever where you had problems?
You mean like from the past?
Yes, from the past. That let you know you were having trouble?
Well,
do you still have that stuff?
I think so. I think it's this actual notebook that I have in my hands.
There you go. So find
the
stuff that gave you a hard time, and we'll go over that stuff. But I already see we got to do fractions. We got to just get basic number sense down, where we can just add and subtract numbers quickly and easily. That's also easy.
Yeah.
But I can usually do that with video. You can watch video on that.
Yeah, it's because it's a little hard to. Oh, here we go. Yeah, I see it here.
Okay. So for next class, maybe we'll cover some of that stuff. I have definite lessons planned for you. I know what I'm doing for the next 2 or 3 times. Okay. And dude, I'll have you up to speed in no time. As you can see. Right? But so far, today? We only did positive ones. We didn't do any negative ones, right? But we're just going to start off easy, baby step our way there.
Right.
And then pretty soon we'll be doing cubes, and pretty soon we'll be doing, right? But I mean, we got to get this down first. You got to get this to where it's easy first.
Right.
And then we can move on. All right. Lesson number 2. Did you have fun?
Yeah.
All right. And see, an hour and a half went by pretty quickly.
Yeah, that was pretty fast.
Yeah. All right. I'll talk to you on Monday. And if you can't make it, tell me on Sunday. Okay?
My phone's about to die.
All right, I can see that. All right, take it easy, man.
Okay, yeah.
Okay.
All right. Bye.
Bye. CrewtonRamone'sHouseOfMath.com for more.